Hi everyone, so for this project I'm doing Shift Cipher. So starting off with the historical background, Shift Cipher was created around 58 BC and is known to be one of the earliest known ciphers created. It was created after Julius Caesar, or was named after Julius Caesar, because he's known to have used this cipher when sending letters to the military about sensitive information. And so he would use this so that others who found his letters wouldn't be able to decrypt and understand what he was writing about. So shift cipher works because um, when you encode, you shift the letters by an n amount towards the right, and then decrypting would be shifting by the same amount, but the opposite direction, so to the left. And compared to modern times, shift cipher is known to be one of the weaker ciphers, just because in modern times there's a lot more harder ciphers. So shift cipher is pretty easy to decrypt because there's a lot of algorithms that are able to decrypt it pretty easily. And it's just a very well-known cipher too, so a lot of people are able to decrypt it pretty quickly and easily. So what is shift cipher? Shift cipher is basically when you shift an alphabet over by a certain amount to create a whole new alphabet. So with the English language, if we start off at A, we can shift it. If the amount was 4, we would shift the new alphabet by 4, so A would be D, B would be E, and then so on. So the new alphabet, this can be visualized by a circle because when you shift over, you want Z to also start off over by A, because if starting at A and it would just be a line, there wouldn't be any more letters after Z. So by creating it as a circle, we're able to just continuously loop over. And when you're programming this cipher, this is what you would be using in order to have the computer basically encrypt and decrypt for you, because you would need it to loop over, or else there wouldn't be anything else that Z can be converted into. So this is the formula given from our class. This is the encryption formula. So the variable P and K, P would be the starting letter, the letter that we want to encrypt, and it's going to be added by K. K is going to be the shift amount, and we're adding it because this is going to be shifting it to the right. And we're using 26 because that's how many letters are in the English alphabet, but this number can be changed depending on what language you're using, because other languages don't have 26 letters. They can have more or less, and we're modding it because that allows us to keep the number within 26. So there wouldn't be any letters that would, or there wouldn't be any letters that would be 27 or up beyond. Decryption is pretty much the same formula. The only difference is going to be this right here, the subtraction sign, because this subtraction sign is going to allow us to shift letters to the left now. So this is how we can decrypt messages. So, okay, for examples, starting off, we'll do, let's just start off with the word practice. Okay, so given the formula that we saw earlier, let's go back to it. So if it's P plus K mod 26. Okay, so we would need to know what P is. So if we start off with the letter P, using this image we have right here, you can see these are all numbered 1 through 26. So P is number 16. So let's do P is equal to 16. And practice. Oops, I forgot the T. Let's have k be equal to 3 for this word. So we're gonna have this be added by 3. So for this entire word, k will always be equal to 3. And then we're gonna do mod 26. Let's do 26. Okay, so this is going to be 19 mod 26. So P is then going to be equal to whatever that 19. So that's going to be S. So we have S now. If we do R, let's see, R is 18. So 18, okay, let's do 18 plus 3, and then mod that 26. Okay, so this is going to be 21. So whatever is at 21, which is U, R is now going to be U. Okay, let's do A. A is 1 plus 3, and then mod 26, so this is 4, which is D. Okay, let's do C up here. C is 3, and then plus 3, so this is 6. 6 mod 26 is 6, so F is at 6. So C is now going to be F. T is at 20. 20 plus 3, which is 23, mod 26 is 23. So this would be W. Next letter was I. I is 9. 9 plus 3 is going to be 12. 12 mod 26 is 12. So L is at 12. So this would be L. C, we have this again. So we can just do F again. And then E is going to be, E is at 5. 5 plus 3 is 8. 8 mod 26 is 8. So this is H. Okay. So from this entire thing, let's do green. The new encrypted word for practice would now be SUDFLFH. Okay, now let's just verify this by decrypting this message now. Oops. Okay, let's erase all of this. And now we're going to remove this, where P isn't going to be equal to K, but now it's going to be subtracted. Oh, oops. And then we have to keep K the same, because that's how we'll be able to and decrypt it again. Okay, so taking this, we're now going to do the same thing, but with the new formula. So starting at S now, we're going to do S, whatever S is, which is 19. 19 plus 3 is going to be 22. And the mod 26. Oh, sorry, I meant subtract. Okay, let's try this again. I think S was 19, so 19 minus 3. Okay, so 16. So now S is going to be whatever is at 16, which is P. Let's try R. R is 18. 18 minus 3 is 15. So 15 mod 26 is 15. So this is... Oh, sorry, starting at U. Okay. U is 21. 21 minus 3 is 18. And then 18 is now R. Okay, so let's fix this. So this is a U, and now this is R. D is 4. 4 minus 3 is going to be 1, so it's A. C is 3. 3 minus 3. Oh, I keep looking at the wrong one. Okay, this is F, actually. So F minus 3. I think F should be 6, so 6 minus 3 is 3. So that's C. L is 12. 12 minus 3 is 9, so 9 is I. C, or F we can reuse again. So this is C from what we got earlier. And then H is 8. 8 minus 3 is 5. E is at 5, so this is E. Okay, now putting this all together, we have P, R, A, C. Did I forget a letter? Pract. P, R, A, C, T, I, C. Oh, I did forget a letter. Okay, let's see. P, R, A, C, D, E, F, G, T, U, V, W. Okay, T should be W here. Let's just do T really quick here. If T is 20 plus 3, 23, 23 mod 26 would be W. Okay, so then now from W, this is 23 minus 3 is 20, so T is at 20. So those two would be equal to each other. So this is T, I, C, E. So you can see from the starting word, practice, we ended up with it again. So this method does work. Let's try with one more example. Okay, let's try a sentence this time. Attack at okay. Let's try putting K at 5. Okay, so starting with A, with that same formula for encrypting, A is 1, so it would be 1 plus, and then K is going to be 5 this time, so this is 5 instead of 3, and then we're going to keep mod still at 26. So this is equal to 6, so F is at 6. So A is now going to be turned into F. T is 20. 20 plus 5 is 25, so 25 mod 26 is going to be 25. So T is now what's that 25, which is Y. And then we're going to do another T, so we can just repeat this to be Y again. There's another A, so we'll just take that from the first one. Okay, C is 3 plus 5, which is 8, so this is H. Okay, K is 11. 11 plus 5 is 16, so new one is P. Okay, Okay, and then A, we did that from the start, so we could just take that. So that's F. We have another T, so we'll just do Y again. Okay, for D is 4. 4 plus 5 is 9, so it's I. We have another A, so F again. W is 5, so because if we do 1, 2, 3, okay, so this is going to be 23 plus 5. Oops. And then if we mod that by 26, okay, this is 28 mod 26, so this is equal to 2. So W is going to be equal to B. So you can see this is the reason why it's visualized as a circle, because from here, if you just count over by 5, it would be 1, 2, 3, and then there would be nothing here. But because if you visualize it as a circle, we could do W, 1, 2, 3, 4, 5, and we'll be at B. So this is why the alphabet needs to be in a continuous, or they visualize as a continuous circle. So at 2, this is B. And then last one, let's do N over here. N is 14. 14 plus 5 is 19. So S is at 19. Okay. So the new encrypted message is now going to be F Y Y F H P and then a space F Y, and this is I F B S. Okay. Now let's take this. We're gonna erase all of this. And then we're gonna decrypt this message to make sure we did this right. Okay. So now going backwards, we're going to subtract. So starting at F, let's look at F is 6. We're going to subtract by 5 now. So 6 minus 5 is going to be 1. 1 mod 26 is 1. And A is at position 1. Y, see, Y is at 25. 25 minus 5 is 20. And T is at 20. Oops. Let's go back. Okay, so Y would be at T. And then another T, or another Y, so we're going to do T again. Another F is A. Okay, let's try H. H is 8. 8 minus 5 is 3, and C is at 3. So this is C. This is P. Looking at P is 16. 16 minus 5 is 11, and K is at 11. So this is going to decrypt into K. Let's do F. We already showed F is A. And then again, Y is T. For the third word, it's I. Looking at I, we have 9. 9 minus 5 is 4. 4 mod 26 is D. It's going to be D. We're going to do F again, but we can just take that. Okay, B. Okay, let's write this one out. This one, B is 2 minus 5 mod 26 negative 3 mod 26. Okay, negative 3 mod 26 is then going to be equal to 23. So that is W S. S is 19. 19 minus 5 is 14. So this is N. Okay, so writing this all out, this is A T T A C K A T D A W N. Okay. So you can see from here the starting sentence that we had, attack at dawn. We were able to decrypt it, and then when we went back to, or this is encrypting, and then when we went to decrypt it, you can see this is exactly the same. So we did encrypt and decrypt correctly. Okay. From the examples though, you can see that using shift cipher is pretty easy to do on your own. So because there's not a lot of steps, you're really just like putting in an equation and then figuring out like what that letter would be equal to. And because K is going to be a constant for each like word or sentence or like the message, it's pretty easy to figure out what K is if you just like happen to stumble upon like an encrypted letter. So it definitely is on the weaker side of ciphers, and like compared to a lot of other ciphers, there's a lot of steps that you have to go through, but it's still since this cipher is also pretty well known, I think a lot of people are able to recognize this pattern, but it's still